Good day, everyone. I've come once again today to teach you. Today, we want to discuss a topic in physics, the topic that some of you find difficult, and that topic is what? Velocity time graph. When you hear velocity time graph, what does it mean? Some people find it very difficult, but I'll show you how it can be solved. Any problem that involves velocity time graph. So follow me and listen attentively. Let me show you the right way of solving any problem that may involve velocity time graph. So let's go. All right, so we have today's topic being velocity. So here we have two keywords. We have velocity. Can you see that? We have velocity here. All right, so the velocity, you have to ask yourself question, what velocity is all about. Velocity has to do with what? Change in displacement, change in displacement over change in time. Change in displacement over what? Change in time. That will give us what? Velocity. All right. So the unit of velocity is that's the standard unit is meter per second. Although you may have some other unit like kilometer per hour and so on and so forth. All right. So velocity is a vector quantity in the sense that it has what? Both magnitude and the direction. All right. In the other hand, we are talking about time. We have time. Right? Time, the standard unit of time is what? Is second. Standard unit of time is second, but that does not mean that we only have time in second. It can be in minutes, it can be in hours, it can even be in days, weeks, months, and so on and so forth. They are still time, but the standard unit is what? Is a second. All right. So when you hear velocity time graph, it means that you are going to plot the first one on the vertical axis. Vertical axis, you can call it y-axis or vertical axis. That means that the first one you mentioned should be plotted on the vertical axis, while the second one should be plotted on the horizontal axis. So if you have graph of W versus you have maybe y like this, it means that this one should be on y-axis, that's vertical axis, and this one should be on horizontal axis. The first one in every graph should be what? On the vertical axis. The second one should be what? On the horizontal axis. Sometimes people find it difficult how they are going to plot this. They don't know the one that will be on the vertical axis and the one that will be on horizontal axis. But the first one you see, just like we have here, should be on the vertical axis. Second one should be on the horizontal axis. When you have distance time graph, the distance should be on the vertical, time should be on what? Horizontal. When you have displacement time graph, displacement should be on the vertical, time should be what? On the horizontal. The first one you mentioned should be what? On the vertical. The second one should be on the horizontal. That's how we plot this kind of graph. All right. So when you have something like this, I noticed again that what people find difficult is how to get the scale, of the graph. All right. So how do I mean by getting the scale of the graph? For example, when you have a graph like this, if I have a graph like this, um, if I have a graph like this, I already have my y-axis and I already have my x-axis here. All right, we are talking about velocity time graph. That means we have something like this. It means that velocity will be on the vertical axis. We have the unit to be meter per second. Can you see? And we have the time to be on the horizontal axis, and we have the unit to be what? Seconds. Can you see that? All right. So now this place is what we call origin. It is called origin. Why? Because at this point, the value of x-axis is 0 and the value of y-axis is 0. So at this particular point, the value of both x-axis and y-axis are what? They are 0. Okay. So that's why we refer to this as origin. That's where everything originated. Can you see that? All right. So when you have something like this, for example, if you have a table like this, maybe you have table like this. I'm just giving an example. If you have a table like this, maybe you have velocity like this. Let's say that this one is velocity and this one is what? Time. Can you see that? All right, so maybe here you have 5, here you have 2, maybe here you have 10, here you have 4, maybe here you have what again? We have 15, here you have 6, here you have 20, here you have what? 8. Can you see that? Then when you have something like this, they say you should plot this velocity time graph. Remember what I said, that the velocity should be on the y-axis, while the time should be on the horizontal axis. All right, so here you have to be doing it in such a way that all the numbers here should be accommodated here. All right, so if I start doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you notice that by the time I get to 20, this y-axis may not be enough for me. Okay, so I'll think again, what about if I do it 2, 2, 2, 2? Will it be enough? If it's enough, I'll do it. If it's not going to be enough, I'll do it what? 5, 5, 5, 5, so that it will be enough. So depending on the height of this vertical axis, whether it can accommodate this or not, that will determine your scale, whether 1 cm will be represented by 1 unit, 1 cm will be represented by 2 units, 1 cm will be represented by 5 units, 20 units, 10 units. You'll be doing it in such a way that every number you have here will be accommodated there. All right, so here, let me do it like this. Now 1 cm will represent what? 5 units. That means here should be 5. Then here should be what? I have 10. Here should be what? 15. Here should be what? 20. Here should be what? 25. In that order. Can you see that? All right. So when I do like this now, you notice that the vertical axis, that it has accommodated every number that I have here. The maximum I have here is what? 20. So I can find 20 here, meaning that it can accommodate this. Is it clear? So what I'm going to do here, I'll have to check. If I do it 1, 2, 3, 4, can it accommodate up to the maximum, which is 8? If I do like this 1, 2, 3, you notice that sometimes on getting to this point, I will be at maybe 6. It means that this last one will not be accommodated. That means that I'm not going to use that scale. But if using 1, 2, 3, that's 1 cm will represent 1 unit, that it can accommodate up to this 8, I'll go ahead and use it. But if it cannot, I may try 2 cm representing, I may try 1 cm representing 2 units. That means I will have 2, 4, 6 to see if it can accommodate this. If it can accommodate it, fine. If it cannot, I'll try again. Maybe I'll try 1 cm representing 5 units. That means I'll have 5, 10, 15. If it cannot accommodate, I'll try like 1 cm representing 10 units. That means I'll have 10, 20, 30, until all this will be accommodated. All right, assuming that 1 cm will represent 1 unit. So here I will have like this 1, assuming that this will accommodate it depending on the space we have in our graph. So when you have something like this, all right, we have this one. Can you see it? All right, so here let us plot the graph. When they say plot the graph of this, we are going to use this table to plot graph of velocity time graph. So what do? I will go to time, which is a horizontal axis, and locate what? 2. Can you see 2 here? Then I'll go to velocity, which is 5. I'll locate like this. So I'll bring this here up here. Then I'll bring this here. They will meet somewhere here. Can you see that? I will have something like this. So when you look at this now, you notice that the velocity is 5. From here, 5. The time is 2. From here, they will meet somewhere here. So we leave it. Next one we have is time being 4 and velocity being 10. So look at 4 here, time, and velocity being 10. So I will come up here, I'll follow vertical line. Then this one, I'll follow horizontal line. Then they will meet somewhere here. So I will have something like this. Can you see that? All right, so that is it. Next one we have is 6. I have 6 here, and I have what? 15. So look at 15 here. I'll follow horizontal line. Then I'll follow vertical line like this. Can you see that? So I'll have something like this. Is it clear? Next one I have is 8, and I have 20. So here I'll come up here. I'll have like this. I'll have something like this. Okay, so let me clean this because it obstructs what I want to plot. All right, so we have like this. This one, I have it like this. Can you see it? They will meet somewhere here. Then I will have something like this. Can you see that? All right, so I hope it's simple. What you are going to do now is that you place your ruler, your meter rule like this. Then you get this like this. Can you see that? All right, so when you get something like this, you say that you have plotted graph of what? Velocity time graph. All right, so it's not difficult. You may write your scale here. I'll write scale like this. Y axis, that's vertical axis. Y axis, I have Y axis like this. Okay, so I'll say 1 cm, 1 cm to 5 units. Can you see that? It means that 1 cm represents what? 5 units. Can you see it? All right, so and the x axis, I have like this. I have 1 cm to 1 unit. Can you see that? It simply means that 1 cm represents what? 1 unit. Can you see that? Depending, it may be 1 cm representing 2 units, 1 cm representing 4 units, 5 units, 10 units. You can choose anyone that is suitable for you. All right, but from what I did now, look at my scale. On y axis, I have 1 cm to what? 5 units, and on x axis, I have 1 cm to 1 unit. All right, so this is the scale and this is the graph. As you can see, we have plotted this velocity time graph, and that's how it can be plotted. All right, remember, this is Engineer Kenneth tutorial. Follow this page and share this video so that it will get to the right students that need to acquire this knowledge in order to get educated. Remember to subscribe to my YouTube channel, Engineer Kenneth tutorial. Thanks for watching this video. Bye.